Good morning, students. Up till now, we have been gone through various chapters like conduction, principle of heat flow, heat exchange equipments, and now we are going for heat transfer to fluid without phase change. So already we have been covered for the thermal boundary layer and hydrodynamic boundary layer. In my last few lectures, I have been covered all these things where we have been seeing this diagram where a hydrodynamic boundary layer has to be formed from the initial point where after the heated area starts, the thermal boundary layer also starts. So this diagram already I have been explained. After that we have been gone through heat transfer by forced convection in laminar flow, where we have been seen three cases, out of which first case was heat transfer to a fluid flowing along a flat plate, where another was heat transfer in plug flow in tubes, and last case was heat transfer to fluid stream after having fully developed flow at the entrance of the tube, where we have been gone through this equation 12.1. Now after deriving this equation, we came to know what is the correlation in between Nusselt number and what is the rate of heat transfer. So accordingly, what is Nusselt number? Hd upon K. Here already we have gone through a lot of numbers like Renault number, Reed's number, Nusselt number, Fourier number. Accordingly, what is Fourier number? Alpha Tt upon Rm square, where alpha is nothing but thermal diffusivity, Tt is nothing but time required for heating or cooling that particular slab, where Rm is nothing but mean radius. So Grid's number and Piclet numbers are also very important in this case, where Grid's number is nothing but it is the m dot Cp upon Kl, where m dot is nothing but mass flow rate, Cp is nothing but specific heat, K is nothing but thermal conductivity, and L is nothing but length of that particular surface. So these dimensionless numbers are playing very important role while to calculate as well as to understand the concept, and these are also having the correlations like if you will talk about the Piclet number. So Piclet number is defined as the product of Reynolds number and the Prandtl number. So what is Reynolds number? What is we have been going through Reynolds number in fluid mechanics. It is nothing but dV bar rho upon mu, where what is the Prandtl number? Prandtl number is nothing but Cp mu upon K. So already we have been going through the definition of the Prandtl number. I told you at the time of discussion in our last few lectures. So by taking the ratio of the absolute viscosity and what was the thermal diffusivity, we are getting Prandtl number, that is the Cp mu upon K. So this Piclet number can be elaborated by taking the multiplication of the Reynolds number and Prandtl number, where finally we are getting d into V bar upon alpha, where d is nothing but the diameter, V bar is nothing but the average velocity, and alpha is nothing but the thermal diffusivity. So friends, you must aware about the alpha. What is alpha? Alpha is nothing but thermal diffusivity, which is also defined as K upon rho Cp, where K is the thermal conductivity, rho is the density, and Cp is the specific heat. So accordingly, Grid's number along with Piclet number, Grid's number is also we can correlate with the Piclet number, which can be defined as